Hey, and welcome to this lesson on congruence in right triangles. Our essential question and our objectives: what special properties of right triangles can we use to prove congruence? So we're going to define the HL congruence test, and we're going to use HL in the proof. Our standards use congruence and similarity criteria for triangles to solve problems and to prove relationships in geometric figures. So what is the HL theorem? HL stands for hypotenuse leg. So when you're talking about right triangles, every right triangle has a hypotenuse and two legs. The hypotenuse, if you don't remember, I'll remind you, is the side that is opposite of the right angle. The other two sides are called the legs of the right triangle. The hypotenuse leg theorem states that any two right triangles that have a congruent hypotenuse and a corresponding congruent leg are congruent. That means that if I have a right angle on one triangle and a right angle on another triangle, and they both have a hypotenuse that is the same length, so they are congruent, and then one of the sides is also congruent, because of the way the right triangle is set up. I have this definite right angle down here, okay, on both of them. I know that my hypotenuse is a certain length and it has to start up here because my leg is a certain length, and because of that it has to intersect with this side. Therefore this side as well down here has to be the same length. Okay, so if these two sides are congruent and then the hypotenuse is also congruent, then this last leg has to be congruent just by the construction of triangles, and therefore since that side is congruent and all the other two sides are congruent, therefore all the sides are congruent, we can use side, side, side to know for a fact that yes, hypotenuse leg theorem proves that two triangles are congruent. Here's an example of what that might look like. Triangle ACB is congruent to triangle ZYX because one leg is congruent to the corresponding other leg. They're both right triangles and their hypotenuses are also congruent. Therefore, they are congruent by the hypotenuse leg theorem. Alright, here's a real life example. On the basketball backboard brackets shown, triangle ADC, angle ADC, which is right here, and angle BDC, which is right here, are right angles. So we can actually even write them as here. So those are two right triangles, and AC is congruent to BC. So are triangles ADC and BDC congruent? Well, what am I given? So I'm gonna write my statements, just like every other proof we've done, and then my reasons on the right. Let's keep us organized by putting them in two different columns, and we'll start a two-column proof. What am I given? So angle ADC and angle BDC are right angles, and that's given. So angle ADC is congruent to angle BDC, both right angles. That's our reason. And then also given is that AC is congruent to BC. And don't forget, we can also say that DC is congruent to DC by the reflexive property. And therefore, I have a leg, I have the hypotenuse, and we know that it is a right triangle because of the two right angles. Therefore, I can say by the hypotenuse leg theorem that indeed triangle ADC is congruent to triangle BDC. So here's what your homework looks like. First, you're going to review some vocabulary with a couple true and false questions. Simply write true or false. Okay. You're going to review a little bit what your vocabulary was. Simply underline the correct words to complete each sentence. Okay. And you're going to identify what is a hypotenuse and what is not a hypotenuse. Then what is a leg and what's not a leg. And then here you're going to be just going through the hypotenuse leg theorem and its conditions. A couple open-ended questions that will ask you about the hypotenuse leg theorem. And then how that all comes together. A couple problems using the hypotenuse leg theorem in a proof. And then you will be asked also to complete a proof using the hypotenuse leg theorem, putting it together, and then a couple questions at the end. If you have any questions, feel free to reach out to me, BBIM, text message, phone call, email, whatever's easiest for you. Meet me in the Math Cafe Monday, Tuesday, and Wednesday at 11 a.m. Or you can go in there anytime from 9 to 3 every single day. There will be a math teacher in there to help you with whatever you need on your assignments. And be sure to meet me in live class where we can discuss this a little more.